Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing vector geometry. We shall be dealing with the relatively easy questions in this topic. So in the first question, we are told OABC is a parallelogram. OA equals P, OC equals Q. E is the point on AB such that AE to EB equals 3 to 1. Find OE in terms of P and Q in its simplest form. So in order to find OE, we need to find a path that goes from O to E. So the path that we have here in this case would be to go from O to A and then from A to E. So the first equation that we write is OE equals OA plus AE. And we start figuring out what it is that we're given and what it is that we need to derive. So OE equals OA, which is basically vector P, plus AE, which we do not know yet. So how do we figure out AE? That will be our task for the rest of this problem. We need to figure out AE and then plug it into this equation on the top. Now, in order to figure out AE, we need to use this ratio here. And in general, it will be always a good idea to write the ratio and add our own term. So AE, we have AE to EB, and AE and EB together form AB because this is AE and this is EB. So together they would form AB. So let's add our own term here, which is term AB. It's always a good idea to write the ratio in terms of the three terms because we will most often try to get AE in terms of the total rather than in terms of the second part. So let's figure this out now. So AE to EB is 3 to 1. We have 3 here and 1 here. And AB is the total. So this would be 4. And this tells us that AE to AB is 3 to 4, which in other words could be written as AE equals 3 over 4 times AB. And this is the equation that we need in order to solve this problem. Now, how do we get AB? So AB is very simple here. AB is parallel to OC. So this is AB, and it's parallel to OC. So AB here is simply Q. So instead of AB, we can write vector Q. So therefore, AE would be 3 over 4 times Q. And that would be the final answer for the problem. P plus 3 over 4 Q is the correct answer here. Notice that you have a method mark for the correct route. So let's just undo here and get the written material. So the correct route is basically this equation here. So you would get a mark for writing this equation, and you would get another mark for figuring out that AE is equal to 3 over 4Q. So what I'm trying to say is that writing the equation of the path or the route is very important, and it contributes to the marks that you are awarded. So let's move on. GHJK is a quadrilateral. GH equals A, JH equals B, and KJ equals C. L lies on GK so that LK equals 3GL. Find an expression in terms of A, B, and C for GL. So we want to find an expression for the vector GL. Of course, this direct path would not work because we do not have the value associated with this path. However, we can try to find some sort of ratio between LK and GL, and we can use that for our answer. So LK equals 3GL. How do we use that? We write down the ratio LK to GL to the sum of GL and LK Let's visualize it here. So this is GL, this is LK, and the sum would be GK, going from G to K. So the sum here would be GK. This is the third element. It's always very important to figure out what the third element in the ratio is. And since LK is 3GL, so the ratio here is 3 to 1. So we have 3 and 1 and 4. Now we want to get GL. So we're going to get GL in terms of the total, which is GK. So we can write that GL is equal to 1/4 times GK. Now that we have our equation, let's get the path of GK. So how do we get GK? We go from G to K, but we don't go down the straight path. We go down the path that we have variables for. So to go from G to K, we're going to go in this direction from G to H, and then in this direction, and then in this direction until we reach K. So GK can be written as GH, this is the path, so GH plus HJ plus JK. So we are given that GH is equal to A. We can write this down in the equation. We are given also that JH is equal to B. And we want HJ, so since the letters are flipped, so this will be negative B. And you can also see it from the diagram. We are moving in this direction, but vector B is moving in this direction, so it has to be the negative of B. Similarly, on the diagram, we are moving in this direction, so we are opposite to C, so it will be negative C as well. Or you can use the letters. This is JK, and we are given that KJ equals to C. So JK would be negative C as well. So therefore, we have obtained an expression for GK. All that remains is to substitute this expression into this equation. So GL would be 1/4 times A plus minus B, that would just be minus B, and then minus C. And this would be the final answer for GL. So their answer is very similar to ours. The only difference is that they distributed the 1/4 over the bracket, but both answers are correct. So this would be correct, and this would be correct as well. O is the origin, OP equals P, OQ equals Q. Z is a point on PQ, such that PZ to ZQ equals 5 to 2. Work out in terms of P and Q the position vector of Z. Give your answer in its simplest form. So position vector of anything is basically the vector from O, the origin, to the letter in question. So we want vector OZ. So we want to go, excuse me, we want to go from O to Z. Let's write down the path. So to go from O to Z, we can go OQ in this direction here, followed by QZ. So OQ plus QZ, that would be a correct path for OZ. OQ is already given as Q. Now we need to find QZ. So how do we find QZ? We use this ratio here. We are given PZ to ZQ. And the total or the sum would be PQ. And the ratio is 5 to 2. So the sum would be 7 for PQ. And we are interested in QZ or ZQ. So we want this ratio here. So we can say that ZQ is equal to 2/7 times PQ. Now we need to get the vector PQ. So in order to get vector PQ, we move from P to Q, but we have to take the other path, of course. So we move in this direction, followed by this direction here. So this direction would be negative P because it's opposing P. P is going up, we are going down. And then this would be positive Q because it's in the same direction as Q. So we can write vector PQ as negative P plus Q. PQ equals negative P plus Q. And therefore, ZQ would be 2 over 7 times negative P plus Q. And this would equal negative 2 over 7P plus 2 over 7Q. This would be the vector ZQ. However, we are interested in vector QZ. So QZ is the negative of ZQ. So that would just be the same vector here, but with opposite signs. So we have 2 over 7P minus 2 over 7Q. Now that we have obtained QZ, we can simply plug it into the equation. So we have 2 over 7P minus 2 over 7Q. Of course, we can simplify Q minus 2 over 7Q. That would give us 5 over 7Q plus 2 over 7P. And that would be the final answer for vector OZ. So 2 over 7P plus 5 over 7Q is the correct final answer here. O is the origin, OP equals P, OQ equals Q, QT to TP equals 2 to 1. Find the position vector of T. So this is very similar to the problem we just solved. Excuse me. So let's solve it again. We want the position vector of T. So we're looking for vector OT. And vector OT would be OP plus PT. We'd go in this direction, followed by this direction here. OP is P, but we need to get vector PT. So let's use the ratio we are given. We are given QT to TP. And the total would be QP. This is the third vector we're going to add. We have here 2 to 1, so the total is 3. We are interested in PT, so we're interested in this vector. We can negate it later, no problem, but we're interested in PT, so we're interested in TP. So we want the relation between these two. So we can say that TP equals 1 over 3 times QP. Now we need to get vector QP. So to get vector QP, you move from Q to P. So from Q to P, that would be negative Q, because we're moving opposite to Q, plus positive P, because we're moving in the same direction as P. So now that we have QP, we can get TP as 1 over 3 QP. So TP would be 1 over 3 times negative Q plus P. And that would be negative 1 over 3 Q plus 1 over 3 P. That would be TP. However, in our equation, we are looking for PT, not TP. So all we have to do is negate the vector. So PT would be positive 1 over 3 Q minus 1 over 3 P, like this. And we can add this into our equation. So we have P plus 1 over 3 Q minus 1 over 3 P. And that gives us 2 over 3 P plus 1 over 3 Q. And that would be the final answer for this problem. And it is the correct answer, thankfully, here. O is the origin and K is the point on AB, so that AK to KB is 2 to 1. OA equals A and OB equals B. Find the position vector of K. Again, this is a similar problem. To get the position vector of K, we want OK. So we can move in this direction from O to A, followed by in this direction here, A to K. So this would be OA plus AK. We are given OA already, so this would be vector A. And we don't know AK, but we're going to use the ratio, of course. as we did before. So AK to KB, and we add our third term, which is AB, and the ratio is 2 to 1 to 3. So because 3 is the sum, and we want AK, so we're linking AK to AB. So we can write the equation AK equals 2 over 3 AB. Now we need to get AB. So in order to get AB, we move from A to B, but not in the straight direction, in the other direction. So we move AO and then OB. So this would be negative A, and this would be positive B. So AB is negative A plus B, and therefore AK would be 2 over 3 times AB, which is negative 2 over 3A plus 2 over 3B. I simply multiplied this fraction by this vector here, and we got AK, so we simply substitute it into the equation. So we have A plus negative 2 over 3A plus positive 2 over 3B, and that gives us 1 over 3A plus 2 over 3B. And that will be our final answer for this problem. In the diagram, O is the origin, OT equals 2 times TD, M is the midpoint of TC, OC equals C, and OD equals D. Find the position vector of M. So this is slightly harder because they didn't give us a clear ratio and they didn't really put the letters on the diagram. So let's put them ourselves. So OC is C. So this vector here would be C. And OD, this vector here, would be D. And we want the position vector of M. So to go from O to M, of course, the position vector of M is OM. So to go from O to M, we can go from O to T first. And then we can go from T to M. So this would be OT plus TM. But in this question, we are not given either one of them. So we need to work to get both of these. Let's start with OT. We are given a ratio for OT. So OT equals 2 times TD. So OT is obviously larger. So we can write down the ratio OT to TD to OD. And then the ratio is 2 to 1. Of course, OT is bigger, so OT gets the 2, TD gets the 1, and the sum will be 3. And we are interested in OT, so let's link these two together. So we have OT equals 2 over 3 times OD. So OT equals 2 over 3 times OD. Now, OD is already given. OD is equal to the letter D. So OT is simply 2 over 3 times D. So we can write down OT as 2 over 3 times D. Next, we need to find TM. So how would we be able to find TM? We are given that M is the midpoint of TC. So when we have a midpoint, this is the same idea as a ratio. You can deduce from that that TM is halfway through the big vector, which is TC. And we can use that in order to find TM. So in order to find TM, first we need to get TC. So how would we go from T to C? So let's create a path going from T to C. So for example, we can use this path here. We can go to TO and then to OC. So TC would be TO plus OC. Of course, you could have gone in the other direction, TD plus DC, that would have also worked. But since we already have OC, our path is easier. So what is TO? We already got OT, so TO would be simply -2/3 times D. And then in order to find OC, we already have that, that's given, so that's just plus C. So TC would be -2/3D plus C. Now, in order to find Tm, we multiply that by half. So Tm equals half times -2/3D plus C. And that would be -1/3D. I'm distributing the half over the vector. So -1/3D plus half C. This is the value of Tm. We add it into the equation. So we get plus -1/3D plus half C. And after simplifying, we get 1/3D plus half C. And this would be our final answer. Half C and 1/3D is the correct answer here. O is the origin, OA equals A, OB equals B. BHF and AHD are straight lines parallel to the sides of the parallelogram. OG equals 3OA and OC equals 2OB. Write the vector HE in terms of A and B. So for question A, we want to get the vector HE. So to go from H to E, we can move from H to F, followed by from F to E. So HE, vector HE, would equal vector HF added to vector FE. Now, we need to figure out what these vectors are, and we can use the ratios to do that. So you should know that any parallel vectors of the same length are congruent to each other. So you can think of this part here as A, and you can think of this part here as B, and you can think of this part here as well as B. And of course, FE as well can be thought of as B. Because we are told that OC is equal to 2OB. So let me explain that in detail, but never mind that for now. So at least we know that AH is B and GF is B. But let's now use the ratios in order to figure out the rest. So we have OG equals 3OA. So let's write a ratio for OG and OA. So we have OG, OA. And of course, here we are given OG, which is actually the total. So watch out, because this is slightly different from what we did before. OG here is the actual total vector. So this is OG, and OA is this part. So the missing part here would be AG. But instead of adding, as we normally did, now we're going to subtract, because OG is the big vector. So if OG is 3 and OA is 1, the remaining part AG is going to be 2, because here the total here is already given, which is OG. So how does this help us? We can think of AG as 2A, because the ratio between them is 1 to 2. So this here, this vector here, would be 2A. And of course, this vector as well would be 2A, because it's parallel and congruent. And this vector here as well would be 2A. Of course, this part here would be A. We're getting everything we can so that when we try to find a path, it will be easy for us to do. Our final step would be to find the other ratio, which is OC equals to 2OB. So let's write this down as well. We have OC and OB. Let's look at the diagram to figure out what the third vector is. So OC is the total vector again. This is OC, and OB is this part. So the remaining part here would be BC. And the ratio between OC and OB is 2 to 1, because OC is double OB. So this is 2 and this is 1. And AB is the remaining part. So it's not the total, so we subtract instead of adding. And this would be 1 as well. So if you remember at the beginning of this problem, I told you FE will be B as well, but then I said I'll explain this as we move through the problem. So this is why we said that FE is B, because OB is equal to BC. So since this is B, this part as well is going to be B. So this part as well is going to be B, and this part as well. So now we have expressions for every single segment in the parallelogram. All we have to do now is just plug into the equation. So HE equals HF plus FE. So HE is going to equal HF, which we have as 2A. So we have that already on the drawing, 2A, plus FE, which is B. So the simple answer here is going to be 2A plus B. That would be the vector HE. And then in B, we are told A plus 2B is the position vector of point what? So position vector means that you're going to start at the letter O. And then you're going to move in the direction A plus 2B. So let's start at O. And then let's move in the direction of A. So 1A. So we move up to here. And then we move 2B. So here is 1B. And then here is another B. So we end up at point D. So therefore, this is the position vector of point D. Next, we're told, write down two vectors that can be written as 3A minus B. So 3A minus B means you're going to move 3A to the right, and then B is up. So we're looking for something that looks like this, 3A minus B. So how can we do that? We need to start at the point on top so that we can move downwards. So let's start at point C, for example. Now, this is A and 2A, so this would be 3A. And then opposite to B, so this would be minus B. So we would end up at point F. So this is the vector we are talking about. So the first vector that would work here is vector CF. And another vector that would work would start at B. So if we start at B, we would move again A and then 2A. So that would be 3A. And then minus B, and we would land at G. So BG would also work as a vector satisfying this equation. Now let's check the marking scheme. So 2A plus B is correct, D is correct, and then CF and BG are also correct. O is the origin and OPQR is a parallelogram. SOP is a straight line with SO equals OP. TRQ is a straight line with TR equals RQ. STV is a straight line, and ST to TV equals 2 to 1. OR equals A, and OP equals B. Find the position vector of T. So the position vector of T is basically moving from O to T. Now to go from O to T, we will move in this direction here, and then in this direction here. So this would be A, and this would be negative B because it's equal to OP. But let's also prove that. Let's use the given to prove that. We are given that SO equals OP. So since SO equals OP, this part here is B, and we are correct in saying that this part here is negative b. And also let's use, just for the future questions, let's use this to evaluate more things on the parallelogram. So we are given that TR equals RQ. Yeah, that doesn't really help us. We already know that SO equals OP, and it's a parallelogram. So we already know that this here would be B as well. So for the first question, OT can be thought of as OR plus RT, and this is equal to A minus B. Next, we are required to find vector RV. So to find vector RV, we move from R to V. Now moving from R to V would be RT plus TV. So this would be RT vector plus TV vector. Now, we already have RT as negative B, and we want to get vector TV. So we're going to have to use the ratio that they gave us, which is ST to TV equals 2 to 1. So let's write that down and try to figure it out. So ST to TV is 2 to 1. In this particular case, you can write SV, but it won't really help because we already want a link between ST and TV. This is because we already have ST. So ST, because it's a parallelogram, so we can say that ST is equal to A. So let's write that down on the drawing. So ST here is equal to A. And we want to get TV. So we don't really care about the total here. So let's write down A. Or actually, let's first get the relation between ST and TV. So we can say that ST is equal to 2 times TV. So A is equal to 2 times TV. So therefore, TV equals half times A. So the remaining part here would be half A. And now we have obtained an expression for RV. Let's write it down. RV equals negative B plus half A. In question B, we are required to show that PT is parallel to RV. So let's get PT first. So to go from P to T, we're going to go first from P to Q. And then we're going to go from Q to T. So from P to Q, this is A. From Q to T, we have negative B and negative B. So negative 2B. So PT would be A minus 2B. So how do we show that RV and PT are parallel? If you can show that PT is equal to a multiple times RV, then you have proven that they are parallel. So is PT equal to a multiple of RV? Let's compare each letter. So here we have negative B. Here we have negative 2B. So we multiplied by 2. Here we have half A. And here we have A. So again, we multiplied by 2. So if you try multiplying RV by 2, you get 2 times negative B plus half A. And you distribute the 2. So you get negative 2B plus A. So 2RV equals negative 2B plus A. And this is the same as PT. So we're going to just say that PT equals 2 times RV. Therefore, PT is parallel to RV. Let's check the marking scheme. So for the first question, A minus B is the correct answer. Let me circle it for you. This is the correct answer for question A. For question B, minus B plus half A is the correct answer as well. And for question B, we can see here that they said PT equals A minus 2B, which is equal to 2 times RV. Let me clear the screen so that you can see better. The idea is to prove that PT equals 2 times RV. OABC is a parallelogram and O is the origin. CK equals 2KB and AL equals LB. M is the midpoint of KL. OA equals P and OC equals Q. Find in terms of P and Q, giving your answer in simplest form, KL and the position vector of M. So for the first question, we are required to find KL. So we can write that, for example, as KB plus BL. And we can try to figure out the value of KB and the value of BL. So to get KB, we're going to use the ratio for the segment where KB is. So where is KB? KB is here. We have this part and we have the total. So we're going to construct the ratio that says CK to KB to CB. And then CK is 2 KB. So that would be 2 and that would be 1. And the total would be 3. We want KB, so we're linking KB. Here we're back to linking to the total because normally the total is the easiest way out. So CB is equal to P because it's parallel to OA. As you can tell from the drawing, OA is here. And CB is parallel and equal because this is a parallelogram. So CB is equal to A. Excuse me, CB is equal to P, I mean. And KB is equal to 1 over 3 times CB. And this is 1 over 3 times P. So now that we have KB, we can write it down in the equation. So KB is 1 over 3 times P. Next, we move on to BL. So again, to get BL, we're going to use the ratio. We have AL equals LB. So BL is here, AL is here, and the total is here. Let's write down a ratio. So we have BL to LA to BA. Now, since AL is equal to LB in terms of length, so we can just write here 1 to 1, and the total is 2. And BA is in fact negative Q, so watch out for that, because AB is equal to OC. So this is OC and this is AB here. So BA would be negative Q. Now, we are interested in BL, so we're going to link BL to BA. And we're going to say that BL is equal to half times BA. And we said that BA is negative Q. So this would be half times negative Q, or just negative half Q. So now that we have BL, we can put it into the equation. And that wraps up our answer for question A. So we can write down KL as 1 over 3P minus half times Q. Now we want the position vector of M, so we want to get OM. So we're going to go from O to M. You can write this as OC plus CK plus KM. Now for OC, we already know that this is Q. For CK, we haven't really obtained CK, but we can obtain it easily from the ratio that we already wrote. So we have CK here. We can link it to CB. You can say that CK equals 2 over 3 CB. And CB equals P. So 2 over 3 times P. Since we already know that CB is equal to P. So we can simply write CK as 2 over 3 times P. Finally, we want to get Km. Now we already have KL and M is the midpoint. So let's draw the segments here. We have Km and ML and KL. So let's write down a third ratio here. We have Km, ML, and KL. And M is the midpoint, so these are equal, and the total, of course, would be 2. So if you want to compare ML to KL, we can say that ML, excuse me, I'm sorry, we want to compare Km to KL. It doesn't really matter, it's the exact same thing, but we are interested in Km here, so let's just write Km. Km would be half KL. So this would be half times KL, and we already have the value of KL since we got it in question A. It's equal to 1 over 3P minus 1 over 2 times Q. And we can expand this to get 1 over 6P minus 1 over 4Q. And that would be the value of Km. Finally, we put it into the equation. So we have 1 over 6P minus 1 over 4Q. And we can simplify. So we have Q and 1 over 4 minus 1 over 4Q. So that gives us 3 over 4Q. Here we have 2 over 3P plus 1 over 6P. That would give us 5 over 6P. And that would be the final answer for OM. So this is the final answer for B, and this is the final answer for A. Let's check the marking scheme. So 1 over 3P minus half Q is correct, and 3 over 4Q plus 5 over 6P is correct as well. ABCD is a parallelogram. N is the point on BD such that BN to ND is 4 to 1. Find BD and CN. So BD is quite simple. This is an easy problem. To go from B to D, we're going to move in this direction and then in this direction. So the first one is negative S, and the second one is positive T. So this would be negative S plus T. Straightforward. For the second one, we want to go from C to N. So to go from C to N, we would take this path followed by this path. So let's write it down in terms of letters. So this would be CD plus DN. CD is basically negative S as well. And we need to find DN. So to find DN, we're going to use this ratio here. We have BN and DN, so we're going to write the triple ratio as usual. BN to DN or to ND, and the total would be BD. Now we are interested in DN, so we're going to link these two together. And the ratio here is 4 to 1 to 5, because BD is the total. So ND equals 1 over 5 BD. So therefore, ND equals 1 over 5 times negative S plus T, which we already obtained in question A. So therefore, ND equals negative 1 over 5 S plus 1 over 5 T. We are interested in Dn, so let's just negate the values. This would be 1 over 5 S minus 1 over 5 T. So let's put it into the equation. Let's plug it into the equation. So negative S plus 1 over 5 S minus 1 over 5 T. And you would get negative 4 over 5 S minus 1 over 5 T. And that would be your final answer for question B. Now that we've circled our final answers, let's check the marking scheme. So we have negative S plus T for the first one. and negative 4 over 5s minus 1 over 5t for the second one. So it seems we have solved this correctly. Now for the final question in this video, we have O is the origin, OP equals 2OA, OQ equals 3OB, and PM equals MQ. OP equals P, OQ equals Q. So let's write these down at least on the drawing. So this is P and this is Q. Find BA and the position vector of M. So let's just try to figure out the given information. We have OP equals 2OA. So we have this segment and this segment here, and the total, of course. So let's write down our triple ratio, OA to AP to OP. We are given that OP is 2OA, so this is 1 and this is 2, and this is the total, of course. So this here would be 1. And we can figure out OA in terms of OP. So OA would be half P. And then AP would also be half P. I'm just getting everything so that we can solve more quickly and more easily. Let's repeat the same thing for the other ratio. The other ratio here would be OB and BQ. Let's draw them here. We have OB and BQ and OQ. So let's write down the other ratio, OB, BQ, and OQ. Now, OQ is the total, of course, and we are given that OQ is 3 times OB. So this is 1 and this is 3, and the remaining segment is 2. So we can write OB as 1 over 3 Q, because this here is Q, and BQ would be 2 over 3 times Q. Now, let's try to solve the actual problem now that we have everything we need. We want BA, so to go from B to A, this would mean that we'll go from B to O plus OA. So to go from B to A, we will go in this direction, followed by this direction here. So BO is the negative of OB, and we already have OB. So we can get BO as simply negative 1 over 3 times Q. And then OA is already found as well. This would be half P. And that's it, and we're done. For question B, we want the position vector of M, so we want OM. So OM would be, for example, OQ plus QM. Of course, you should know that you can also write this as OP plus PM. It doesn't really matter. Now, in order to find OQ plus QM, of course, we have OQ. OQ is simply Q, and we want to find QM. QM is part of the segment QP. We have QM, MP, and QP. Let's write the ratio down. QM, MP, and QP. Now, the ratio here is dependent on the fact that PM equals MQ. So you're given here PM equals MQ in terms of length. So therefore, the ratio here is 1 to 1, and the total would be 2. So we are interested in QM, so let's link QM to QP. QM is equal to half of QP. Now, in order to get QP, we go from Q to P. So this would be QO plus OP. So QO is the opposite of OQ, so this is negative Q. And OP is P. So we have QP, and we can get QM simply by multiplying by half. So half times negative Q plus P. This is negative half Q plus half P. So QM is negative half Q plus half P. And we can calculate by simplifying. We have Q minus half Q, so half Q plus half P would be the correct answer. So therefore, OM equals half Q plus half P. So let's check the marking scheme. We are given -1/3Q plus half P for the first one. I forgot to circle the final answers, excuse me. So these are our final answers. So for the first one, we have -1/3Q plus half P. For the second one, we have half Q plus half P. These are correct. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.